Hi everybody, Jonathan here. In this video, I will be giving you my take on section 3.2, the product and the quotient rules. Now, first off, I like to change the notation up a bit when I think of the product and quotient rules in order to make them easier to remember. So instead of writing f of x times g of x, I write LR because L stands for left and R stands for right. And this is nice because if you only think of it in terms of f and g, you might be given a problem where f and g means something else in the context, and then you don't want to let f be the left function. However, I've never seen a problem where they use capital L and capital R for function names. So with this new notation, the product rule now says that the derivative of a left function times a right function is equal to the left times the derivative of the right plus the derivative of the left times the right. Now, using the same ideas with the quotient rule, if t is the top of a fraction and b is the bottom of a fraction, then the quotient rule says that the derivative of the top over the bottom is equal to the bottom times the top's derivative minus the top times the bottom's derivative, all over the bottom squared. Now, the book does lots of nice examples of these, and you should practice these on your own as well. And since I'm not interested in repeating what the book does, I just want to add what you do when you have to combine rules. So right now, we don't know that many functions to differentiate, so I can't really think of an interesting problem where you would have to use the product rule multiple times. However, as soon as we learn about the derivatives of trigonometric functions, that'll change. However, it is easy to come up with problems where you're going to have to use the product rule as part of using the quotient rule. So for example, if f of x is equal to x squared e to the x plus x, all divided by the square root of x minus 7, then you're going to have to use the quotient rule because, well, this is obviously a fraction. However, if you think about it, when you go to take the derivative of the top, then that's going to involve an application of the product rule. Now, something that helps me do these types of problems when you've got to apply several rules is instead of taking the derivative right away, I just make a note that I need to take the derivative. And then once I have pretty simple derivatives, I can apply the rules to relatively simple functions. So since f of x is a fraction, f prime of x, by the quotient rule up here, is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So f prime of x is going to be the bottom, which is the square root of x minus 7, but since I'm substituting in, it has to be in parentheses. And then we need to multiply that by the derivative of the top. Notice I haven't actually calculated the derivative of the top here yet. I've just noted that it needs to be done. And now we subtract the top, which of course also has to be in parentheses because you're substituting it in, times the derivative of the bottom. And once again, I'm not actually calculating the derivative of the bottom. I'm simply noting that it needs to be done. And then we divide the whole thing by the bottom squared. Now, by the sum and difference rules, we get that this is equal to the square root of x minus 7 times the quantity of whatever the derivative of x squared e to the x is, plus whatever the derivative of x is, minus the quantity of x squared e to the x plus x times whatever the derivative of the square root of x is, minus whatever the derivative of 7 is, and then all over the square root of x minus 7 quantity squared. Notice here, all I've done here is since the derivatives break up nicely over sums, I'm just taking the derivative of these two parts separately as seen here. And really, I'm not even taking the derivatives yet. I'm just noting that I need to take the derivatives. And I'm doing the same thing with the square root of x minus 7 here. I'm just noting that I have to take the derivative of each part. Now that we've got pretty simple derivatives in place, well, actually, before I even do that, I'm now going to use the product rule, but just do it abstractly on this x squared e to the x. So that's going to get replaced with the left part, x squared, times the derivative of the right part, plus the derivative of the left part times the right part. And I still haven't actually calculated any actual derivatives. But at this point, it's all been broken down so that we have nothing but simple derivatives, so we can go ahead and finally calculate the answer. So all I have to do is say what the derivative of e to the x is e to the x. So this line here is the same as this. I've just calculated the derivatives. And then here I've replaced the x squared with a 2x and everything else being the same. Here I've replaced the derivative of x with 1. Here I've replaced the derivative of the square root of x with 1 over 2 times the square root of x. And while I didn't write it in, the derivative of 7 is just 0, so I didn't bother writing it. And then I don't make you simplify, so you're welcome to leave your final answer like that. All right, well, good luck trying to do this on your own.